just a quick introduction to what the chain rule is. So the chain rule, there's going to be two different cases in two variables, because in the one variable case, what we had was a function that is evaluated at some other function. So a function of x, a function of t, and I'm evaluating f at x equals g of t. And then we know how to take derivatives of that. In two variables, there's two opportunities to do this. We can do f of, I have two variables, right? So I can plug two different things for g and for h. And now I'm going to have to be able to take a derivative of that. Notice that this was, in this case, f here was a two-variable function, and it became a one-variable function because I evaluated both of them at something that depends on the same parameter. But we can do more complicated things, and we could evaluate at things that are also multivariable. So we can do something like g of s and t, and evaluate here at g of s and t. And then here, I could only take derivatives with respect to t. Here, there's only one variable to take derivatives, so we want to know what is the derivative with respect to t. But here, the result, it is a two-variable function with respect to s and with respect to t. So we are going to be able to take derivatives with respect to s and with respect to t. So this is the old chain rule. This is the one parameter, and this is the two parameters. So that's what we're going to be doing here. So just to remind you, again, if I have a function f of x and then a function g of t, then f of g of t, I can take the derivative with respect to t, and the derivative here is the derivative of f evaluated at g of t times the derivative of g of t. We can write that as, what is the derivative of f of g with respect to t when I evaluate? And we simplify this sometimes as this is the derivative with respect to x, and then the derivative of whatever it is in x with respect to t. This is identified with this factor here, and this is identified with this factor here. So when you take a derivative in a one-parameter case, we'll do that next time. When you take a derivative with respect to one parameter, like I said, you have a function in two variables, and you're going to evaluate x as a function of one variable and y as a function of one variable. When we take the derivative, there's going to be a formula that depends on the derivative of f with respect to x, the derivative of f with respect to y, and it's going to give you the total derivative by putting those two things together. So we will continue on this next time.